So as you guys all know, we were at the liquid state chapter and we were just started that chapter, and now today we'll be discussing about, as you guys all know, in the previous video discussed about the liquid state. And liquid state we have discussed the van der Waals forces, and there were three forces. Number one was hydrogen bonding, dipole, as well as you can say that the London or dispersion. Okay, so today I'll be discussing about their properties, but let me give you the overview of the previous video. So as you guys all know, the viewer the liquid state, and they were having intermolecular forces. Okay, so they are formed by gases and by cohesive force. What is cohesive force? Or you can see that the van der Waals force. Cohesive force is a force, okay, that is inside a molecule. Okay, so we were having three van der Waals forces. Number one was hydrogen bonding, second one was dipole, third one was London. Okay, so we were three forces we were having. Okay, so if we talk about the hydrogen bonding, that was the strongest force between just in all these strongest force. Okay, high electronegativity, then they are more polar. Okay, this is dipole force, which is weaker, and the force which is having a polarity but less polarity. Okay, if we talk about this one, so they were having a less electronegativity. If we talk about London or dispersion, that was a weakest force among these three, and this was a, you can say that temporary, this is a temporary force. Okay, so there is too much less polar, or you can see that they are having no polar charges, like no charges, no, too much less polar. Okay, so if we talk about the properties, so if someone asks you that what is, which force is having high state of liquid character, that is, as you guys all know, that is hydrogen bonding. Why? Just because there is the strongest force, and H2 is also the example of the hydrogen bonding. And if you talk about dipole, we are having HCl, and in this we are having example that you can take the iodine, bromine. Okay, so these are what, so the next property, that is someone asks you that which force is having more boiling point, so we are having hydrogen bonding. Okay, just because we want more boiling point to break this force, because this force is too much strongest, so we were having a more boiling point, that is of hydrogen bonding. For example, we are having a H2O, NH3, and this one hydrogen. Okay, hydrogen fluoride. So this is, so through among these, this is having more boiling point, just because they are attached with like you can say the bilateral. For example, let me make the example of the H2O. We are having H2O molecule. First one, we are having a molecule H2O. Okay, this is a molecule, positive, negative charge, positive charge, and we are having a second molecule. This is that. Okay, so negative, positive. Okay, so again, between this oxygen and hydrogen, we are having a hydrogen bonding, and hydrogen oxygen, we are having hydrogen bonding. So here you can see that this is bilateral. This is two molecules of H2. This is bilateral. Okay, here you can see O, oxygen, and hydrogen are chemically attached. So we can say that one molecule of H2O are bonded by two angles, or you can say that you can say two hydrogen bondings. Okay, so this is the bilateral. If we talk about the this one, hydrogen fluoride. So we are having this one, you can say that hydrogen fluorine, hydrogen. So here you can see that we are having a hydrogen bonding between minus charge, and they are having positive charge and minus charge. So you can see this is what, this is a unidirectional, unilateral. Okay, if we talk about this one, okay, so this is like, you can say that they are having many direction, then they are attached with the 3 hydrogen, this one. Okay, this ammonia is attached with 3, so no, this is not attached, this is attached with 3, but because of this is having more attraction among these 3, so why we consider that as a hydrogen point, and why not ammonia? So just because they are having more attraction, but they are less, the if we talk about nitrogen, so in this nitrogen is less electronegativity, so we had not considered that as a this molecule as a high boiling point, because they in this, you can say that the ammonia, the nitrogen is having less electronegativity, so that's why we are considering hydro water as a more boiling point. Now if someone asks you that which force is having less boiling points, we can say that is London on dispersion, because they are non-polar and they are having a less attraction. Okay, so if someone asks you that which you can say that which forces can vaporize more, so we can say London or dispersion force, just because as you guys all know, in London dispersion there is less attraction, so that can easily vaporize. If someone asks you which force is more stable, as you guys all know, we are having a strongest force, that is hydrogen bonding, so that is more stable. If someone asks you that which force is volatile, which forces can volatile easily, or which force is having more volatility, what volatility, okay, so that we can say that that is London, because of the less attraction. For example, you can take the example of petrol, that can easily volatile. Okay, or you can say that high fumigation, these are having which force is having high fumigation or volatile power. Okay, if someone asks you which force is having high density, so we can write here hydrogen bonding, it's easy. If someone asks you which is, you can say that the more which is having more solubility, like as you guys all know, everything can dissolve in water, so just because of the solubility, so water is example of hydrogen bonding. So hydrogen bonding is having more solubility power because they are polar. If someone asks you that which force is having more electrical power, electrical conductivity, as you guys all know, through if our for example my hands are wet, okay, and if I can, you can say that if my hands is touched into any kind of a socket, and that, so it will give me a current just because of the my wet hands, just because of the water. So which is having a more electrical conductivity, that is hydrogen bonding, that is water, just because of the current, you can say that, and they are having charges, so just because of that we can, you can say that they are having more electrical conductivity. If someone asks you that what is non-directional force, so we can say that all forces just because of the polar, and you can say that charges are scalar, they are having no direction, so they are non-directional. All forces are non-directional. So this were some kind of a properties about these van der Waals forces. So in the next video we'll discuss about a new topic, that is surface tension.